Hello everyone, we are Team DroneX and today we will be presenting a project titled Autonomous Disaster Management and Surveillance using Drone. This project focuses on using autonomous UAVs to assist in disaster response, human detection and emergency supply delivery. Disasters, whether natural or man-made, cause severe damage to infrastructure and results in loss of life. One of the biggest challenges during such events is obtaining real-time info from affected areas. Often, these zones are inaccessible or unsafe for human responders, which delay rescue operations. Based on this challenge, the problem statement is to design autonomous UAV system that can survey disaster zones, detect humans, and provide emergency aerial support without continuous human intervention. But the current limitations is that disaster assessment relies heavily on ground surveys and manned aerial operations. These methods are time consuming, expensive, and pose serious risks to rescue personnel, especially in unstable environments. Our solution is an autonomous drone platform designed to overcome these limitations. How we'll achieve that is by using the key features like autonomous navigation, in which the drone operates autonomously without continuous human control. It follows predefined or dynamically generated paths, allowing it to survey large areas efficiently even when communication is limited. SLAM-based mapping allows the drone to build real-time maps of unknown environments while simultaneously tracking its position. This is especially useful in GPS-denied or obstructed disaster zones, such as collapsed buildings or dense urban areas. Obstacle detection and avoidance is done by using sensors combined with SLAM. The computer vision or the human detection, we use computer vision techniques such as based on OpenCV and YOLO V5 deep learning model. The system is trained specifically to detect humans in real time with from aerial imagery, enabling quick identification of survivors. Then the payload dropping system, once a human is detected, the drone can deliver emergency supplies such as first aid kits or food packets using onboard payload dropping mechanism, providing immediate assistance until rescue teams arrive. So the project execution is that we follow a systematic phased development approach. This allows us to test each module independently, simplify debugging, and gradually integrate both software and hardware components. In the initial phases, we prepared the Raspberry Pi development environment and deployed the YOLO model. We validated our navigation and detection logic in a simulated environment using SITL before moving to hardware testing. The core module includes a YOLO-based human detection system and an autonomous navigation module using waypoints. SLAM integration enables localization and mapping in GPS unavailable environments. The decision-making logic ensures payload drops occur only when safety conditions such as altitude, stability, and battery level are satisfied. The payload mechanism was designed and 3D printed, and all components were carefully integrated for stable operation. Here is the components cost breakdown. We selected off-the-shelf hardware to keep the system cost-effective while maintaining reliability. This includes frame with PDB, brushless DC motors, electronic speed controllers, propellers, flight controllers, which is Pixhawk, GPS module with compass, Raspberry Pi, the Raspberry Pi camera module, the micro servo motor, RC transmitter and receiver, and the LiPo battery. So, from a feasibility standpoint, the project is technically viable due to mature drone hardware and existing algorithms. Autonomous operation improves efficiency and safety, and the modular approach allows completion within academic timelines at a reasonable cost. In this, the key success factors depends on reliable human detection, efficient autonomous operations, regulatory alignment, and human-centric design approach that ensures safe and reassuring aid delivery. So, to conclude this, the expected project completion timeline is around uh, 12 months away. In conclusion, the system bridges the critical gap between locating survivors and delivering immediate aid during the golden hour, enhancing survival rates while reducing risk to responders. Thank you.